Alright guys, we're going to learn how to do some factoring. It's just review, so it's an easy lesson because we're going to move into piecewise functions and you have to be able to factor to do piecewise functions. Okay, so there's a difference between two problems here. So take out your journals, title and factoring notes, and we've got these two problems to look at. Number one, actually, x squared minus 10x plus 21. I move the order around first, okay? Then, when there's no leading coefficient, in other words, no number in front of x squared, that's the easy one. So all you gotta do is open up your parentheses, okay? Put an x in both spots. And remember the little trick? You want numbers that add here and multiply here, like a.m., the morning, a.m. So numbers that multiply to give me 21 would be like 1 and 21, 3 and 7. Okay, there they are. 3 and 7 make 10. So I'm going to fill those in. Okay, and I want a negative 10, so they both have to be negative. So I've factored. All right, now number 2, 5g squared minus 13g plus 6. This problem's a little harder because it's got the leading coefficient. So when you have a leading coefficient, you have a couple extra steps. You're going to take this 5 and the 6 that's here, and instead of multiplying numbers to give you 6, you multiply numbers to give you 30, 6 times 5. So when I have a leading coefficient, I like to make a little table, okay? I want numbers that are going to multiply to give me 30, and numbers that are going to add to give me negative 13, the same as the number in the middle. So list factors of 30, 1 and 30, 5 and 6, and then maybe 3 and 10. Those are the ones that are going to give me 13, right here. So I'm going to put those numbers down, okay? And remember I was telling you it had an extra step? You know how in order to get this 30, you had to multiply it by the 5? Well, now you have to divide that back out. And I like to put it as 5g, okay? Because that's going to help you, because 5g. And then you look at these answers and you see, okay, does 3 over 5 reduce? No, so that one's good. And then you check this one, but this does reduce. 5 fits into both of these. So put a clean line through it and this becomes 2 over 1g, or just g. So then there's your answers. I write them as 5g plus 3. Okay, so 5g plus 3 and g plus 2. So I did 5g plus 3 and g plus 2. Let's go to the next one. Number 3, 6r squared minus 7r plus 2. It has a leading coefficient, that's 6. So that's the one where you have to do the extra work. So you want numbers that are going to multiply to give you 6 times 2, which is 12, and add to give you this middle term. So you want numbers to add to give you negative 7. So I just come over here, I think about things that multiply to give me 12. 1 and 12, 2 and 6, okay, 3 and 4, right? I'm looking for numbers that give me 7, which there they are, 3 and 4. So I'm gonna put my numbers here. I want a negative 7 to be added. So that means they both have to be negative. But go back to the beginning. When you have a leading coefficient, I multiplied the leading coefficient in to get my 12. Now I have to divide the coefficient back out. And I'm going to write it as 6r. So divide it back out, 6r. Then remember, you look at these as fractions. Does 3 over 6 reduce? Yes, it reduces to 1/2, right? So I'm going to say, okay, let's reduce that. Negative 1 over 2r. And you could actually type this in your calculator. Negative 3 divided by 6, math, enter, enter, and it will give you negative 1/2. And then I'm going to check this one. Does 4 over 6 reduce? Yes, or 2 fits into both, so negative 2 over 3r. And there's your answers. 2r minus 1 and 3r minus 2. Guys, it's just an algorithm that works every time, like a trick, to help you factor without guessing and checking. That's what this is. Okay, number 4 is negative x squared minus 3x. You'll notice that on this problem, there are only 2 terms. So if there's only 2 terms, then you need to look for a GCF. Okay, if there's only two terms, then look for a GCF. You're going to factor it a different way. Okay, do these have something in common? Yes, this has an x and this has an x. And because I'm leading with a negative, I'm going to factor out a negative x, right? So if I take an x out of here, I'll still have an x left over. If I take an x out of here, I've got a 3, right? So there's your answer. Go to the next one, number 5. Number 5, remember I told you it only has two terms, x squared and 25, so you're going to look for a GCF first, okay? Is there a GCF? Do they have something in common? Nope, they don't, okay? So then when you only have two terms, the other thing you want to look for is perfect squares. Okay, are these perfect squares? Yes, x squared is perfect squared, and 25 is perfect squared. Then you'll notice it has a minus in the middle, right? Remember, we call this a difference of perfect squares. So the way you factor that, remember, is the square root of x is x, and the square root of 5 is 5. So it's just x plus 5 and x minus 5. Okay, number 6, 2x squared minus 8. And once again, it only has two terms, so you're going to look for a GCF. Does it have a GCF? Is there anything in common? Yeah, a 2. A 2 will fit in here and give me x squared, and then a 2 will fit in here and give me 4. Then again, you look carefully at this answer. If you go back up at number 4, all we had was an x minus 3. Neither of those are perfect squares. However, on number 6, I would have to take the 2 out. X squared is a perfect square, and 4 is a perfect square. So if they're perfect squares, remember we go again. The square root of x squared is x, the square root of 4 is 2. So then that means this is x plus 2 and x minus 2. Okay? All right, now let's go to the next one. Again, there's 2. What was the rule when there's only 2? Right, remember your first step? You're going to look for a GCF. Do they have anything in common? And yes, they both have a 5. So let's take the 5 out. You get x squared plus 3. And then second, you look at the rest of your answer, and are they perfect squares? Well, x squared is a perfect square. But is 3 a perfect square? Can you take the square root of 3? No, you cannot. So you're just going to leave it like that. Okay, number 8. Right, for number 8, you've got 3 terms now. Now, not only do you have 3 terms, but you also have a leading coefficient. So that's the problem where you have to take these and multiply them together. So you want numbers that multiply to give you 3 times 10, which is 30. And you want numbers that are going to add to give you that middle term, 11. So if we list factors of 30, 1 and 30, nope, doesn't make 11. 2 and 10, no. Okay, and it's 5 and 6, right? So you write the 2 numbers down, but the answer isn't x plus 5 and x plus 6. You had this 3 that you multiplied in, so now you have to divide the 3 back out. Once you do that, you see if this fraction reduces. 5/3 doesn't reduce, so it's good. So I just write my answer as 3x plus 5. But 6/3 does reduce. It becomes 2 over 1x, or just 2 over x. So that part of the answer is x plus 2. So then you have your final answer. Okay, now we have one last problem, number 9. X squared plus 8x plus 15. X squared plus 8x plus 15. This is another easy problem because it does not have a leading coefficient. When you don't have a leading coefficient, just set yourself up a set of parentheses. And then your AM trick, you want numbers that add to give you 8 and multiply to give you 15. right? So then your x goes here and here. So what are factors of 15? 1 and 15 doesn't give me 8. 3 and 5, there it is. So you just put your 3 and 5 here, and then check your signs. Everything's positive? Yes. Okay, now you can do your worksheet, and please be sure to turn your worksheet in by the end of the period. Thank you.